This is the second in our video series of how we use artificial intelligence to read land records. My name is Alex Weeks. I'm the president of Electra Digital. Electra is a software company and we write software to process land records and aircraft records. Today we're talking about computer vision. And when I introduce computer vision, I like to first talk about what computer vision is not, because there's a lot of misconceptions out there. Computer vision is not a video camera. It's not the camera on your iPhone. Computer vision is a piece of software that takes that image data and converts it into something that the computer can understand. So just like our eyes are how we see the world, but it's our optic nerve that converts our vision into electrical impulses that our brain can understand, well, you can think of computer vision like the optic nerve of the computer. Computer vision is a common product. It's how law enforcement reads license plates. It's used in assisting or sometimes just outright diagnosing CAT scans and MRIs. It's used in diagnosing kidney disease, and the list goes on. So chances are pretty good that you've benefited from computer vision. In our world, computer vision means that we can see a document in its entirety. And this gives us context about what the document looks like, what document it is, and it allows us to provide this context information to the artificial intelligence engine so that it knows ahead of time what it's reading. You can imagine that a mortgage obviously is going to have very different information on it in different places than a tax lien. And so the more information we can give Gemini about what it's reading and what it's doing, the better quality information we get back. So to jump into this, we're going to pull a particular part of the document out. We're going to look at the document stamp and look at how Gemini reads that section of the document. I chose the document stamp because it's a notoriously difficult part of the document to read. It's added to the document after it gets to the county clerk's office, and so it's not part of the original document. It's not in the same font. It's not in a normal location. It's often applied by a stamp machine, so it can be crooked, it can be skewed. And all of those things make it very difficult for traditional optical character recognition or OCR systems to read it. But with computer vision, we have a new toolbox that's available to us that we didn't have previously. We can now take this document and pull it apart and look at each section individually with computer vision. And that allows us to examine each section in its own context, in its own right, and we get much better results from the AI system. So let's look at how our product, Gemini, would jump into a traditional instrument. Let's say that we've got a 20-page mortgage. The first thing that Gemini is going to do is it's going to look at the first page and go to the second. It's going to read that document end to end. It's just going to look at all 20 pages. When it does that, it's essentially getting the lay of the land. It's looking at how it's formatted, it's looking at the margins, it's looking at the scan quality, it's looking at the fonts that's used, and all that type of general information. After it's done that, it comes back to the first page, and it's going to pull the individual sections of the first page out. It's going to identify the title, it's going to identify the body section, it's going to identify the footer and the header. And what it does is it draws virtual bounding boxes around each of those sections, essentially the coordinates on the page for where each of those sections are. And that allows it to come back to that section and look at just that section independently in the appropriate context. So we're interested in the document stamp. Let's go up to that top section up there. Let's look at the bounding box that Gemini drew around that document stamp. We're going to pop that stamp out of the document. We're going to crop the rest of the document away from it. We're going to do some rotating and deskewing and enhancing to help the quality of the read. And then Gemini is going to do something super important. Gemini is going to switch into stamp context. It's going to switch into the appropriate context for the section of the document that it's reading. And this is a very important part of the process. When it switches into stamp context, it knows that it's looking for coded information, knows it's looking for an instrument number, book and page, a date. Most importantly, it knows it's not looking for party names, it's not looking for property description. And so essentially by dropping into this specific stamp context, Gemini already knows the answers to some of the questions before the question's even asked. And that gives us better results back from the process. So Gemini is going to jump into the stamp. It's going to pull each of these data fields out. It stores them in a temporary database where we store this information while we're reading the document. And then after it's done with the stamp, it's going to move into the other sections. As you can imagine, you can see the pattern. It drops into the appropriate context for that section, reads that section, pulls those data fields out, and puts them into the temporary database. Does that through the entire document until it's finished. So at this point, once it's finished with the document, we've got good high quality reads out of the document. We've pulled the data fields out that we need and we've stored them in our database. But there's an important part of the process that hasn't happened yet. we haven't done any common sense check. And anyone who's ever worked with these automated systems before can tell you that it's easy, even with the best systems, for some garbage to get through. And so we need to run this through a common sense check because we're not ready to put this information yet into a title plan. So Gemini switches gears. It drops into validation mode. And Gemini predominantly uses a time-based analysis for validation. So I'll give you an example of that. Let's say that Gemini, through its neural network and pattern recognition tools, has figured out that whenever it sees a deed, it's likely to also see a mortgage. Well, Gemini can move forward and backward through the daily documents and even into neighboring days to look for that associated mortgage. When it finds it, it's going to do the same analysis we just described on the mortgage, and then it's going to line the data fields up. It's going to look at where it has matches. Do the parties match? Does the property description match, etc.? And when it can find either exact matches or what we call near duplicates, then it can self-validate. Basically what it has at that point is two independent reads of two separate documents, both of them read the same. So it'll be pretty sure that it read that correctly. Another example might be, let's say we have a lien release. Gemini is smart enough to know that if we have a lien release, there's another document somewhere in the previous filings that created that lien in the first place. So Gemini goes back through those documents looking for that original document, the document that created the lien. And so it can go back 1,000 or 50,000 or 100,000 documents looking for that. When it finds it, it's going to do the same analysis. It's going to line up those fields, match them up where they can, and validate that information. So if Gemini can't validate its own information, then it scores that field low enough that it has to go to a human reviewer for verification. If it can find a matching document, but it can't match those fields up, it also won't score it high enough, so it has to go to a human reviewer. But in the cases where it does match and gets a score above that threshold, it can self-validate, and those fields can pass through without any additional human intervention. So at that point, all of the data that's stored in that local database goes into a download file, gets downloaded, usually inserted into a title plant, and that's the end of the process for that document, and then it moves on to the next document. So next up in video 3 in our series, we're going to jump into the data science and data mining tools that we use to go back 10,000 or 100,000 documents. I hope you come back and join us. I think you'll find it interesting.